Okay, so we are going to do the day one practice. Let's see, the first one, it says draw a circle around the function that are linear. So I'm looking for the linear functions. A linear function is going to make a line. So that means it's x to the first power. All right, now this is x to the first power, but see how it's in the denominator? So that's not linear. It has to be in the numerator. So this is x to the first power. This has an x to the first power, but there's a higher one, so this would actually be quadratic. And of course, you can always check if you're taking a test by putting this in Desmos and seeing if it makes a line. If it makes a line, it's linear. Then it says make a box around an absolute value function. So absolute value function has these straight up and down lines. So that would be an absolute value function. Here's a straight up and down line. So when you see that, that is absolute value. All right, and then now we are looking at the characteristics of absolute value functions. So if I see a v, that is going to be an absolute value function. Absolute value function. Makes everything positive because that's the distance from 0, and the distance is always positive. So the vertex, we know, is the top of the V, or the, wherever the top, it could be the highest point or it could be the bottom, right, the lowest point. Okay, and so that would be, in this one, it's -1, +4. The axis of symmetry is going to divide, it's going to be a line that goes through the vertex. All right, and it's a vertical line so it's going to be x equals something. It goes through the vertex. So where does it cross this x-axis? Right here. So my axis of symmetry here is going to be x equals, and then it crosses the x axis at -1. And then notice that is always related to the vertex there, right? The x coordinate of the vertex is -1, so my axis of symmetry is -1. Now the equation of the parent function is going to be f of x, because that's our function notation. That just means y equals, but we'll say f of x equals, absolute value is the up and down straight line. So absolute value of x. How far is this number from 0? Domain left to right. So this goes forever to the left and it goes forever to the right. So the domain is going to be -infinity to +infinity. All right, because it's at this angle. So it's going left and right forever. Range is going to be bottom to top. Well, it goes down forever, so that it's going to be -infinity. And you have to always put the smaller number first. And then it goes up to the vertex here. That's the maximum. And so that would be when y is 4, right? Range is always the y value. So it goes from -infinity to 4. No minimum, all right, because it's upside down, it goes to -infinity, but there is a local maximum, right, which is this vertex here, right? That is the top of the hill there. So that would be, and if we want it as an ordered pair, that would be -1, 4. If we wanted just the maximum value, we would just put the 4. Increasing means I have a positive slope as I go left to right. And so if I look at the left-hand side, that's a positive slope. So that's an increasing interval. But what I'm going to write down is the x values where it's increasing. Okay, so these are the x values right here where it's increasing from -infinity till it gets to the vertex, which is -1. So from -infinity to -1, these are x values that I'm putting in for my intervals. I want the decreasing interval. Well, that's the right-hand side because that's a negative slope. It's going down as I go left to right. It's going down. And so that is